Everyone enjoying the conference so far? Woo, woo, woo. Okay. So, special jump for you, Diana Gastrin with Python behind the scenes. Please give her a warm round of applause. Thank you.
Hi. Do you hear me well? Yes? Fine, okay. I'm Diana. I came from Tel Aviv, Israel. And today we're going to talk about Python behind the scenes. So I have a BSc in computer science. And back then, I took a course about the principles of programming languages. And it was very enlightening for me because it's looking differently on each programming language. And I took some things from there and applied it to the Python language. So I hope you'll enjoy, and it will be innovative for you. I'm a software engineer for 7 years, 8 years maybe. I don't remember. For the last 3 years, I work at Apple, also as a software engineer. And when I have free time, I really like to do side projects. For example, this one. This is a bad smells indicator. When the light is red, the smell is not good. And when it's green, it's OK. So we are here to talk about Python. The agenda for today are 3 main topics. The one is objects in Python. Second one is variable scoping. And the last one is evaluation rules. So we start with the objects in Python. What is an object? It's a Python abstraction for data. And there are 3 attributes that define an object: the value, ID, and type. So the value is the actual content. The ID is where it is at the memory. The memory is the heap. All the objects are in the heap. So it is the address. And the type can be int, str, bool, float, dict, and so on. So if we look at the example on the right, in line number 3, you see I do num equals 12. Num is a variable. 12 is an object. And because it's an object, we have ID of num. It has a long number that represents the memory address. It has also type, which is class int. And also, type is an object. It has type, ID, and value. So this is mind-blowing. All the data in Python is an object, eventually. So there is another attribute that I would like to talk about, which is the reference count. It means how many pointers we have currently that are pointing to this object. So if we look at this example on the line number 3, num equals 12, there is one pointer that points to the 12th object. But if we do, so the sys.getRefCount will return 1. But if we do num2 equals 12, then currently the reference count incremented by 1, and it looks like this. There is a memory optimization here. We could create 2 different objects and to point for each object separately. But I will talk about this at the end of the talk, so stay tuned. OK, now I would like to talk about 2 attributes, value and type, and we'll start with the value. The value can be immutable or mutable. Immutable means that it's read-only. Once we define the object in the memory, we know how many bytes it needs, so it's faster access, it's memory optimized, and we cannot change it. So an example for this would be numbers, frozen set, strings, tuples, and so on. On the other end, we have mutable objects, which are read-write, and we can change them dynamically. For example, list, we can add items, set, and more. So if we define a class, a user-defined class, by definition, it will be mutable, because we can add attributes on the fly. And there is a way to make it immutable. One way is by adding the underscore slots, underscore, which is a class variable. If you look at this example on the right, I defined class point. And this class is mutable because we can add attribute z after the initialization. And if we want to make it immutable, I just added the slots variable that includes x and y. And when we initialize these both classes, it will be the same. But the only difference, the huge difference between them, is when we look at the size. When we initialize a mutable class, which is point, it will be 308 bytes. When we initialize an immutable, it's only 48 bytes. It's really huge difference. And when there is a new version of Python, when there is a new release, for example, in Python 3.8, there is always a section of optimizations. And this section included a memory optimization for the UID class object that they added the slots to this class, and it reduced 100 bytes for this one. Why it's important? Because if you use databases, for example, Postgres, then the primary key is most of the time a UUID object. And imagine a large database with a lot of rows. So it's really significant. And I added here a barcode if you want to see how it looks when you push code to Python code base and all the discussion there. It's very interesting. So this is slots. Now I would like to talk about type. In the programming language world, we have two types of type, static and dynamic. Static is when you define a variable that is bounded to the type itself and to the value. So it means when I define int x equals 5, I cannot change the type of this variable. It will forever be an int. An example for languages that do static typing is Java, C, C++. And on the other hand, we have the dynamic type. When you define a variable, it's just a pointer to an object, and this object can be of any type that you want. It can be string, it can be int. Python is like that. It's dynamically typed language. And specifically, the type is duck typing. If you know, there is a famous quote, if it walks like a duck and it quacks like a duck, then it must be a duck. Exactly here, if the function can execute the method, so we'll execute it. Here, in this example, you see class 1 on line number 1. And then you see get total that returns a string total. In line number 5, you have class 2 with get total that returns 10. Class 2 and class 1 there is an inheritance between them. So when I try to execute get total of class 1, I will get the string total. When I try to execute the get total of class 2, I will get number. So this is the duck typing. It doesn't care about data types. It just cares that it can execute the method. OK, so once we covered these types, we can go to the next topic of this talk. So it's variable scoping. Variable scoping, there are 4 main environment variables: the built-in, the global, the enclosing, and the local one. The built-in, if we start with that, this is something you get for free. You don't need to do any import to get this, and it includes the built-in constants and the built-in functions. For example, the true and false constants, and the sum and str methods that you get for free. If you want to see what this list includes, you need to import built-ins and do dir on these built-ins and get the full list. This is for free. After the built-in environment, we have the global environment, which we have only single one. Only one environment, it is the global. And all the variables that are defined in our code that are outside of any function, they are considered global. So if you look at the global symbol table, we have global var. In line number 1, we defined it. It's outside of a function. And we have global f, which is the method itself. And so this is the global environments. One way to find all the globals that you have in your code is by looking at line number 6 and to call the method globals. It will return it in a dictionary with a beautiful indentation. OK, so now we have also the local environment. The local environment are all the variables that you define inside the function. And once you define a variable inside the function, there is a local symbol table. As you can see on the left side, the tables, there is a global symbol table. And then it has the local symbol table, which includes the f1 and arg1, which is the arguments of a function are also local. And a way to find locals is by executing the locals method, similar to the global. So now I have a question for you. What would be the output in this section of code? We have global var equals 1. We have a function global f in line number 3. And we have global var equals local arg plus global var. Who thinks it will print 3? OK. More? OK. Who thinks it will print 1? It would be nice if it would be one person, but I have here 2. OK, so it would be print unbound local error, local variable global var, reference before assignment. This error is not self-explanatory. We need to understand what it means. So what it means that if we look at this table, we have in a global symbol table global var and global f, and then we go into the function, and we define local arg, which is 2, and Python works left to right. It first adds the variable name, then it assigns it a value. So when we try to understand what is global var, we put it in the table. We don't know yet the value, and when we have another global var on the right side of line 4, we just don't know what is the value, and we throw an error. And it makes sense because there is ambiguity here. The question is if you want to change the global environment, or you want to define a local variable inside your function that will not be related to the other scope. So the solution for this would be to, to add the global keyword. The global keyword which explicitly tells change the global environment. OK. Now we're approaching to our last environment, which is the enclosing one. The enclosing one is when we have nested functions. So every outer scope of a function, the variables inside will be included as enclosing one. As you can see in the example, we have the global symbol table with global var and global f, the enclosing symbol table with arg1, f1, and arg2. And we have the local, which includes the arg4. As you see, it's inside function 2. So now I have a question for you. When you see this code, we have global var, we have arg2, and we want to see in line number 10 what is the value of arg2. Who thinks it will be 2? Nobody? OK. Who thinks it will be 3? OK. It might be 3, yeah? Who thinks it might be 3? OK. So same. Unbound local error, local variable arg2, reference before assignment. And now, because we understand what happened with the globals, so if we look at the solution for this is to use non-local. When you use non-local, it means that we go into the enclosing environment, and we are changing the argument from there. OK. So this was the summary of the variable environments. Whenever we have a variable, first we look at the local environment, then we are going to the enclosing, to the global, and then the built-in. If it's not in any of these environments, we'll get an error, will be said. So this was the part of the variable environment. I would like to talk about the private methods, which is a scope inside the class. So there are no really private methods in Python, but there is a way to do it, like I will explain. If we define a class, every method with a prefix or the underscore is considered private. So if you see, we have the public method in line number 2, and we have the private method with line number 5. So when I try to execute the private method, what do you think it will? Who thinks it will print private? Because I said there are no really private methods. Who thinks? Nobody? One thinks, two. OK. So it won't print private. It will give me the non-self-explanatory error, attribute error, class with private object has no attribute private. And this is weird. So the way to understand this is by looking exactly what we have in this class using the dir method. And as you can see, there is a different name for this method. Python just took the class name and the method name and concatenated this. And this is the name. It's like fooling us. It's like, no, it's not. There is no private method. There is class with private underscore private. So I told you that there are not really private methods because we can execute it and bypass it by using the new name. OK, so this was the part of the private methods. Now we are approaching to our last part. I hope you enjoy, and I hope it's innovative for you. So we are going to talk about evaluation rules. We'll start with Boolean comparisons. So it's important to understand what is a false value. False value is every object with len that equals to 0. The size of the object is 0. This is a false value. Sorry, I have here an error, but it's OK. And a way to find the false value is by the if-else clause. It will behave differently. And we can define by ourselves the behavior of our class with the bool method. So this is important to understand because we're going to understand the not operator, which when it gets a false value, it will return true or false. As you can see, not on dictionary in line number 1, it returns true because empty dictionary is false value. Not on a non-full on a dictionary with items, it will return false, and not on one, which is a true value, will return false as well. Unlike the not operator, we have an and or operators, which are not returning true or false. They actually will return the object itself. So or will return the first value that is not false, and will return the first value that is not true. And if you look at the example on the right, line number 1, we have two false values, the empty dictionary and the empty list. And because we are using and, we are just returning the first value that is not false, and we stop the evaluation. On the second line, we see we have two false values with or. Or will return the last object, even if it's not a true value. It will return empty list. And in the examples below, in line 4 and 5, we see the example with true values. So and will return the last true value, even if it's not false, and or will return the first value because it meets the condition. And as I said, we stop the evaluation, and this is called short-circuit evaluation. When we know the result, we stop the evaluation, and we do not make any more. We stop and return. And a good example for this, as you can see, in line number 1, we have empty dictionary and ABCD. ABCD is unknown. It's just it's not a variable. It's not something that we know in our environment. It's not in the built-in. It's not in the global. Nothing. So in the end case, it will return empty dictionary because it's a false value. It will not reach to ABCD. And in the second example, when we have or, it will, when it has empty dictionary, it's a false value, so it continues with the evaluation, and it will try to return ABCD, and it's a name error. So this is a good example to understand when it's a short-circuit evaluation or not. OK, so we have Boolean operators, and we have comparison operations. The comparison operation, we have chaining one. Here you see a function sum AB that prints sum and returns A plus B. And the result of number 1 and number 2, number 1 is chained comparison, number 2 is not, is the same. They will, both of them return true. But there is difference between them, and the difference is the side effect. What does it mean? That the chained one, they will call sum function only once. It will output only one sum. And the second one will call it twice. So there is an optimization there that we don't see it, but it appears. And there is another comparison that I would like to talk, and this will be the end of this talk, the is operator, which compares between the addresses of an object. How to get the address is by using the ID. Here you see x equals 256 object, and y equals 256. They are both equals, the value is the same, with the equals in line 4. They are both at the same address. As you can see, they have the same long number. And then when we try to do 257, they have the both value, but they are not in the same memory address. And this code happens only in the interactive mode, because there is, in the interactive mode, when you run it from the terminal line by line, there is an optimization that when you start a Python code, it caches all the objects between -5 to 256. So for every number between those -5 to 256, it will return true. And for every new number, it will not return. When you run it from file, there is an optimization that we cause it to return true. So what about strings? It's interesting. So in strings, every name with a space will be a new object. So as you can see in number 1, A space B and Y equals A space B, they are not in the same memory address. It's a new, completely new object. But if it's without space, if it can be a name of a function, then there is an optimization, and it will be at the same memory address. And this something that is happens in the interactive mode and the non-interactive mode. So it's interesting to see it as well. So this was the ending slide. Thank you. And I hope you enjoyed. And no, there is one more thing. There is one more thing, as Apple says. So I brought, you remember I talked about my side project? So this is my cat, Alberto. I talked about my side project, so I brought 3 of them with me. And if you have below the seat where's the metal a note, then come and get your prize. It looks like this, the prize. It's below the metal.
So we're the lucky winners.
Yeah. We found one.
Okay.
Who else? No, yeah, this is the metal below. I can tell which line if you want me to spoiler, to give you a spoiler.
How many developers does it take to find a feature?
Line number 3 in this section. Chair number 9. 1, 2, 3, 4, 5, 6, 7, 8. You won. You won. Did you see? No? Below the metal. Yeah. There's the. Ah, yeah, he found it. Okay.
Okay.
So,
Perfect. Perfect, Diana. Apart from the little gifts, we do have some questions in the chat. Are you ready to answer those?
okay.
So first question is, some sources say slots was primarily a Python 2 optimization and that its memory gain mostly diminished after Python 3.3. What is your opinion on that matter?
It is part of Python 3.8.
Yeah, it is, but
Yeah.
okay. Second one, from a software engineering perspective, is it a good idea to use global and non-local? If yes, in what circumstances? Thank you.
I don't think it's a good one because it makes your code hard to read. If you want someone to hate you, so use this.
Okay. Oh, perfect. Oh, now you can hear me. This is so cool. Next one. How about private properties compared to private methods? For example, there is a convention for spatial data classes geointerface.
I don't know.
That is a good answer. And
But it's interesting. I will read about this.
I think so. With that, thank you very, very much. Warm applause again for Diana. Thank you.
Thank you.
So next up,
Enjoy.
guests, we're now on lunch break, so please enjoy your lunch and have a great rest of the conference. Thank you.